Hi, I'm Mario Trapelli, and welcome to Dr. Mario Trapelli Presents Awesome Astronomy. Here joining me today is Dr. Isaac Coretti, PhD and MD, and to his right is legal insane astronomy enthusiast Jesse McKee.
Hi.
How are you two doing today?
Great. Woo-hoo!
Jesse, I believe you have some questions for us experts concerning astronomy.
Yes. What is astronomy?
Astronomy is the branch of science that deals with celestial objects, space, and the physical universe as a whole.
Whoa, big words. My next question is, what is a celestial object?
Celestial objects are naturally occurring physical entities, associations, or structures that current science has demonstrated to exist in the observable universe.
Whoa! I'm a big fan of Goofy. He has a friend named Pluto. Is Pluto really a planet?
Actually, Jesse, Pluto is not one of the 8 planets. It is a dwarf planet. A dwarf planet is a celestial body resembling a small planet, but lacking certain technical criteria that is required for it to be classified as a planet.
Oh! I saw a cool movie over the summer called Gravity. What is gravity?
Gravity is the force that pulls together all matter. There are 2 requirements to instate gravity.
One being how much mass is in an object. The more mass, the more gravitational pull it exerts on other objects.
The other being the distance between the 2 objects. The closer the 2 objects are, the more gravity is exerted.
Yippee! What would happen if God hit the light switch of gravity?
Earth and the other 7 planets would not orbit around the sun, and objects would not stay in place.
Also, there would be no such thing as weight, only mass.
Yummy! Who discovered gravy?
Gravity was discovered by Sir Isaac Newton, who recorded all the principles of gravity in the late 1600s.
You may know the famous story where an apple plunked Newton on the head, thus causing him to realize the effects of gravity.
I am getting word from the studio producers that we have some live callers. Let's go to them now.
Dr. Trapelli, thanks for taking my call. My name's Brian from Weedville, and I have to first say that I thoroughly enjoyed your research on the theory of relativity. I thought it was very thought-provoking, and in that regard, I have a question with regard to space travel. Can you tell me how traveling at the speed of light affects space travel? Thank you.
As long as there is any substance of hydrogen in your spacecraft, and you travel at the speed of light, there will be so much radiation that you will kick the bucket in an instant. And now, a question from Maria Trapelli from Weedville.
Hi guys, this is Maria from Weedville. First of all, I want to say how much I love your show. Dr. Coretti, I have a question for you. What are supernovas, and exactly what do they do? Thank you.
A supernova is a stellar explosion that is more energetic than a nova. A nova is a star showing a suddenly large increase in brightness, then slowly returning to its original state in a few months.
And now, to Luann Trapelli from St. Mary's for our last question of the
Hey
day.
guys, it's Mom. Luann from St. Mary's. Hey, I have a question for you guys. What exactly do black holes do? If you can answer that.
I know this one! Black holes grow in mass capturing nearby objects within 10 miles. Anything that enters the event horizon cannot escape the black hole gravity, so the objects that do not keep a safe distance get swallowed up.
Good job, Jesse.
I got one right!
It's now time for today's Teaching Tidbit.
Today's segment is on the Big Bang.
Wowzers!
The Big Bang is a theory that many scientists use to theorize how the universe was created.
Nebula began to collapse under its own gravity and spin faster. A dense clump of matter formed in the center. It's called a protostar. At first, its heat was due to friction, but when the clump reached 18 million degrees Fahrenheit, nuclear fusion kicked in. 4.5 billion years ago, our star was born. Hydrogen atoms fuse together to form helium, and in the process, release photons. It's the first light made by our sun, and it will keep on shining for 4 billion years. A vast nuclear furnace, nearly 1 million miles across. From a distance, this process seems almost peaceful, with the sun's power gently radiating out into the early solar system.
There was all sorts of activity going on. Things were changing rapidly, violence, explosions, intense radiation. We had a pretty spectacular origin.
Recent research suggests the solar system's birth was far from peaceful. Our sun may in fact have been born out of one of the most violent events in the cosmos. The explosive death of another star. And even before that, it seems there was an explosion so huge that it created an entire universe. The Big Bang. No one knows what caused it, but we think that the Bang created space, time, and all the matter in the universe. Yet for astrophysicists, such as Professor Stan Woosley, there's a puzzle. The Big Bang produced almost none of the 88 naturally occurring chemical elements.
When we look around, we don't just see hydrogen and helium. We see planets and people, and we're made out of carbon and oxygen, and planets are made out of iron and silicon. And that didn't all come from the Big Bang. It had to come from somewhere else.
Here on Earth, we have learned how to create new elements for ourselves. Nuclear technology. The same thing happens inside stars. Hydrogen and helium from the Big Bang fuse to form heavier elements. And if the star is big enough, at the end of its life, it does something spectacular. It explodes.
The energy of a supernova explosion is essentially equal to all of the energy that the sun will put out in its 10 billion year lifetime.
Go. Many physicists estimate that the Big Bang occurred approximately 13.82 billion years ago.
Indeed, Dr. Coretti. According to the Big Bang model, the universe started as a dense, hot state, and it expanded and is still expanding today.
Whoa! So that means the galaxy is growing and growing to this day?
Yes.
Goody! I just learned something. Yay!
After the initial heat blast that was caused by the dense state, the cosmos cooled down significantly, allowing subatomic particles to form, like protons, electrons, and neutrons.
I hate those darn electrons. They always zap the bazinga out of me.
Yes, Jesse, they can. Electrons are responsible for making this video possible.
That reminds me, we will now go to commercial break, but stay tuned because we will be right back. Electrons, electrons,
I'm the nucleus!
they are flying through the electron cloud. Electrons, electrons, making this video possible. To you, the electrons,
To our famous viewers,
to you, to you,
to you!
now let's go back to
The show.
the show. Awesome Astronomy. Welcome back to Dr. Mario Trapelli presents Awesome Astronomy. We will now return to our earlier broadcast topics.
Thank you, Doctor. As we were saying, the most common atoms in the universe were mainly hydrogen with helium and traces of lithium.
Good point, Dr. Isaac. Speaking of which, gravity eventually formed giant clouds out of these elements. which are now called
stars.
correct, Mr. Insane.
I think I should become a scientist like you, Phil.
That about does it for today's episode of
Awesome
Astronomy! Until next time, I'm Dr. Mario Ciappelli.
I'm Dr. Isaac Coretti.
And I am Mr. McKee.
Thank you, and we'll see you next time.